Section 3.2, the derivative as a function. So in this section, we define derivative as a function. So previous section, section 3.1, we define derivative using limit. So we are going to use the same definition here. But when we find the derivative, in general, that would be actually, the function of x. If we are finding the derivative in term of x. So the derivative of the function f of x with respect to the variable x is the function, this is the notation f prime, whose value at x could be any number, any point, is defined by using this limit. So if you try to find the derivative, you need to find this limit, okay, provided that this limit exists. And sometime we can also express the derivative using this formula, but both of them should give you the same answer. One thing we have to keep in mind that if function is f, any function has a derivative, that means that function is continuous at that point. So derivative implies continuity. If f has a derivative at point C, then f should be continuous at that point. So in this section, we're going to see a couple of examples. First example is using the definition, calculate the derivative of the function, then find the values of the derivative at specified point. So this is the function. We use either this one or this one to find the derivative. Finally, because that derivative is the function of x, we're going to replace that x by -6, 0, and 1. Okay? So let me just use this definition. F prime of x, which is derivative of this function, can be found by using this formula fx plus h minus f of x over h. So this is the difference quotient. So let's find out this limit here. So fx is 8 minus x squared. Fx plus h is, just replace this x by x plus h. And now square of x plus h is x squared plus times xh plus h squared. Now just distribute this negative sign here. So eventually it will be 8 minus x squared minus 2 times xh minus h squared. So we're going to use this value here. Limit h approach to 0. Copy that. 8 minus x squared minus 2 times xh minus h squared minus f of x is this value. Because there is a negative sign here, and we distribute this negative sign here, we need to change the sign. So this becomes 8 plus x squared over h. So remember, whenever we try to find out this limit, always simplify on the top such that you are going to get a factor h, so that you will be able to cancel this h. This 8 and this 8 cancel out. This x squared and this x squared cancel out. Now find out the factor out the h. As you can see that there are two terms, this one, and both of them have h. So we can factor out h, and we can write down the leftover thing, negative 2x minus h over h, and cancel this. Now if we try to find out the limit, just plug h equal to 0 here. So it would be negative 2x, negative 0. So this is the derivative of this function, negative 2x. As you can see here, derivative of the function f of x is negative 2x. But if we try to find out the derivative at some specific point, we just have to replace this x by that point. For example, in our case, we would like to find out the derivative of the function at -6. So just replace this x by -6, which is negative times negative is positive 12. Derivative of function at 0, just replace this x by 0, which is 0. finally the derivative at 1, just replace this x by 1, which is eventually -2. Okay, here is another problem. Differentiate the function. So this is the function, meaning find out the derivative, then find equation of the tangent line. Remember, the equation of tangent line means you need to use this formula y minus y1 equal m times x minus x1. And to find out the derivative, we can use this formula, find out the derivative, and find out the derivative at a specific point 0. Okay, by using the very similar trick here, like that, you can find out the derivative. So that gives us slope, limit h approach to 0, f at 0. So either I can just use this general definition, or I can just put x equal to 0 here at the beginning, which is like from the previous section. So for me it would be easier if I just plug 0 plus h minus f of 0 over h. So find out the value of this function at 0 plus h, which is 6 plus square root of 1 minus h. Just replace this x by h, and for this one just replace this x by 0. So it would be 6 plus square root of 1, which is eventually 6 plus 1, which is eventually 7 over h. So 6 minus 7 is minus 1, so it's h approach to 0, square root of 1 minus h minus 1 over h. So to find out this limit, we need to just multiply the numerator and denominator by the conjugate of this one. By doing that and simplify further, you just multiply the top one, that would be square root of 1 minus h square minus 1 over h times square root of 1 minus h plus 1. If you simplify further here on the top, we're going to get 1 minus h minus 1 over h times square root of 1 minus h plus 1. This negative 1 and this positive 1 is cancelled out, and now on the top there is a negative h, on the bottom there is h, square root of 1 minus h plus 1. This h and this h cancel out. Now finally, to find out the limit, just plug h equal to 0 here. It will give you square root of 1, which is basically 1 plus 1 is 2, so it will be 1 negative 1 over 1 over 2. So that's the slope of this curve at point 0. So now we need to use this formula. For this formula, just plug x1 is 0, y1 is 7, slope is half. That will give you the equation of tangent line. Just, here, the equation of tangent line is y minus y1, which is 7, slope is negative half, x minus x1, which is 0. Okay, 7 half x, just add 7 both sides, that will be y equal negative half, um, half here, negative half x plus 7. So this is the equation of tangent line. Find the equation of tangent line at the indicated point on the graph of the function. So this is the equation of tangent line. So here, this notation d over d theta, this is also this notation is also called derivative. This is also derivative. So we have given function r is this one. We want to find out the derivative of that function at a specific point when theta is 1. So we can use the very same formula, limit formula, this one, find out the derivative. This case it's a function of theta, so r prime theta, which is actually dr over the theta. This is r prime theta. That's the same thing. This can be found when h approaches to 0, r theta plus h minus r theta over h. Don't be confused with this r. This r is like a f. Okay, it's just a function of theta. Here we have given r is 5 over square root of 10 minus theta. So if r theta is 5 over square root of 10 minus theta, then r theta plus h is 5 over 10 minus uh, theta minus h. Okay, so here if you want to be specific and find the value when theta is 1, you can replace that theta by 1 at the beginning. You can do that. That will reduce your problem. So want to find out f r prime when theta is 1, so we can use the very same formula and replace this theta by 1. Okay, so to find out the value of r at 1, you just have to replace theta by 1 here. That will be 5 over square root of 10 minus 1, which is square root of 9, which is 3. So 5 over 3, that's r of 1. R of 1 plus h is 5 over 10 minus 1 minus h, which is basically 5 over square root of 9 minus h. Okay, we can use this expression here and find out the limit that will give us the derivative at point 1 when theta is 1. So let's let me just add one blank page here. I'm going to plug r1 plus h equal to 5 over square root of 9 minus h. So r over d theta when theta is 1, it's actually r prime of 1. That's the same thing. The derivative of r with respect to theta when theta is 1 can also be written as r prime of 1, which is, in our case, it's r1 plus h, which is 5 over square root of 9 minus h, 5 over square root of 9 minus h, minus 5 over 3, 5 over 3 divided by h. So we just have to simplify this. Simplify this, we have to make the same denominator. For that, we can multiply this numerator and denominator by square root of 9 minus h, and this one by 3. Okay, by doing that, on the top you can see that 15 minus 5 minus square root of 9 minus h over 3 times square root of 9 minus h. This h also goes here. Now our goal is to just simplify this thing on the top. We can simplify because of this radical sign. Simplify this thing on the top, we have to multiply the numerator and denominator by its conjugate. So it will be limit h approach to 0, 15 minus 5 square root of 9 minus h. Before multiplication, we can factor out 5 here. That will reduce our problem. So if I factor out 5, it will give me 3 minus 1 times square root of 9 minus h. So it will give me 3 minus square root of 9 minus h. So this is 3 minus square root of 9 minus h. If I factor out 5 from the top, the bottom there is a h, 3 times square root of 9 minus h. So we need to simplify the top one in a way that we can find the factor h on the top one, so that we can cancel this h on the bottom one. So I'm going to multiply the top one by 3 plus square root of 9 minus h over 3 plus square root of 9 minus h. Okay, by this is the conjugate. By doing that, uh, on the top we are going to get 5 3 as you can see that if you multiply the conjugate, it will give you 3 square minus square root of 9 minus h square, which is eventually 9 minus h. So it will be 3 square minus square root of 9 minus h square uh, over over h times 3 s times 3 times square root of 9 minus h times 3 plus square root of 9 minus h. Look at here what happens. On the top there will be 5, there will be 9 minus 9 plus h. There is h, there is a 3, there is 9 minus h, there is 3 plus square root of 9 minus h. This positive 9 and negative 9 cancel out. Now the only thing on the top would be 5 times h. So we can cancel this h and this h. Okay. So because this 9 minus 9 is gone, so the leftover thing would be 5 times h. So h on the top, h on the bottom can be cancelled out. So now to find the limit, we just have to plug h equal to 0 here and here. So it will give us 5 over 3 times square root of 9. 9 minus 0 is 9. 3 plus square root of 9. Square root of 9 means it's a 3. So eventually it's a 5 over 3 times 3 plus 3 plus 3. So 3 times 3 is 9. 3 plus 3 is 6. 6 times 9 is 54. So 5 over 54. So that's the answer for this problem. The derivative of r with respect to theta when theta is 1 is 55 over 50. Next problem, find out the derivative by using alternative definition. So I'm going to do this one. So for this one, you have to find out f of g, which is 5 plus square root of 5 times g. So find out the difference between them. F prime of x is the limit g approach to x. On the top, it's a 5 plus square root of 5 times g minus 5. Because there is a minus sign, so you need to change the sign here. It will be square root of 5x over g minus x. So in this case, instead of h, we are using g minus x. So we have to come up with the factor g minus x on the top such that we can cancel out this g minus x from the bottom. So at this point, this 5 and this 5 is gone. Now we have the square root of 5g minus square root of 5x. So to simplify this thing further, we have to multiply the top one and then bottom one by its conjugate. Whenever we have this radical sign, to get rid of this radical sign, we have to multiply the top one and bottom one by its conjugate. Conjugate means same terms but opposite sign. By doing that, you can see by doing that, we have um, limit e approach to x. By doing that, on the top, if you look at here, this times this gives you square of the first term, which is the square of radical sign, this square root. So it will eventually be 5g on the top minus 5x. Square of the first one minus square of the second one gives us 5g minus 5x. On the bottom, we have g minus x times square root of 5g plus square root of 5x. So on the top, if you just simplify, just factor out 5, it will be g minus x. On the bottom, there is a g minus x as well. So we can cancel this g minus x and this g minus x. That's the whole point of doing this simplification. Now we can just replace g by x. To find out the limit, just replace g by x. On the top there will be 5, on the bottom there will be 5x square root of 5x plus square root of 5x, which is eventually 5 over 2 times square root of 5x. Okay, so if you don't want the square root down here, then we can just multiply the top one and bottom one by square root of 5x, which will give us 2 times 5x. We can cancel this 5 and this 5. So eventually The answer for this problem is square root of 5x on the top over 2x on the bottom. So that's the derivative. Okay, sometime we can find many information about the derivative by just looking the graph. For example, look at this graph here. Look at this graph here. Uh, Now our goal is to graph the derivative of this graph. So at least what we know is, if we try to draw, derivative means slope of the tangent line. Slope of the tangent line. If you take any point here and draw tangent line, you can see that slope of this line, it's going down. So the slope would be negative. Slope would be negative. Draw tangent line and find out the slope. Until this point where that slope, the tangent line would be horizontal tangent line. So the slope at this point is 0. After this point, at any point, if you draw the tangent line, the slope would be positive. So the only thing we can find out from this graph is the slope on the left side of this point. On the left side of this point is negative. At this point, the slope is positive. After this point, the slope would be positive. Okay. The slope on the left side is negative. At this point, the slope is 0. And after that point, the slope is positive. So the graph of the derivative would be negative up to this point. We don't know what is this point. So let's say this is some constant number. Let's say some positive number. Up to that positive number, the slope would be negative. After that, the slope would be positive. So using just this information, and if we have to plot the graph, then that would be difficult. But we can use this information to choose the graph. If we have given, let's say when you do the homework problem, you have these options available, and now you need to choose the graph, which one represents the derivative of this graph. Then you know that until this point, this derivative would be negative. At this point, the derivative would be 0. After this point, the derivative would be positive. So look at here. In this graph, there is a positive, 0, and negative again, positive, and then again 0. So this is not the right one. Here, all positive. This is not the right one. Here, some negative, 0, and positive, and again 0, and again negative. So this is not the right one. If you look at here, until some point, this point, the slope is negative. The value of this graph is negative. And after that point, the value of the graph is positive. So it satisfies the property. The graph has to be negative until this point. At that point, graph has to be 0. And after that point, graph has to be positive. So we can choose, if we have given options, then we can choose the graph of derivative of the function we have given.